Welcome to GRIDFLEX and another video clip. My name is Hannes Schweiger from Ioneum Research in Austria. As we already finished our interview series with all GRIDFLEX partners providing specific information about the rule in the project, we now focus on the GRIDFLEX tools. Today, it's a pleasure to welcome Diego García-Casarrubios from ETRA, who is going to give a short presentation of the tool GRIDFLEX and its quality characteristics. Hello, Diego. Nice to meet you, and thanks for being our host today.
Hello, Hannes. My pleasure.
So I think you can now switch to the presentation mode, and we would looking really forward to your presentation about the GRIDFLEX tool.
Okay, so I introduce myself again. I'm Diego Garcia from ETRA in Spain. I'm a software engineer, and I've been in charge, together with my team here at ETRA, of the development of the GRIDFLEX tool, which is the advanced automatic control and observability of the flexible grid tool. Let's start by taking a look at the GRIDFLEX ecosystem. So it's mainly composed of 4 technical tools. In the center, there's the GRIDFLEX platform, which deals with the management of the data and the communications among all the other 3 tools and the assets in the field. Then we have SERVIFLEX, the tool for the aggregator, the MarketFlex for the market operator, and what we will see today is the GRIDFLEX tool aimed at the grid operator, mostly the role of a DSO or a microgrid operator. We can continue by taking a look at the challenges that we faced in order to, previous to developing the tool. So we have summarized them in these 3 points. So first of all, there's an increasing share of distributed renewable energy sources in the grid, which introduce some variability and uncertainty of these sources. So there are different kinds and with specific characteristics, each of them. And they also may include or may carry with them some risks and challenges to the stability and the security of the grids. We are also going towards a decentralized ecosystems with these new energy systems, such as batteries, power to heat, vehicle to grid, and some others. With these new technologies, there's a large flexibility potentials to be offered to the grid. And but on the other side, these types of systems are normally operated by third parties. So there's a need for coordination and cooperation among the different actors in the grid in order to achieve this management and share of flexibility. And we also identify the necessity of interaction between the transmission and the distribution systems. So it's something that we have included as some use cases in our tool, specifically for DSOs to support the TSOs in stress operating conditions, and including, as we previously mentioned, the end customers or as active participants in the operation or on the everyday operation of the grid. Talking about the main achievements that we have reached with the GRIDFLEX tool, we have integrated the data sources and systems in the 4 pilots that are included in the project. So Albena in Bulgaria, Xanthi in Greece, and Luce and Raunena Koroškem in Slovenia. So we are receiving data through the GRIDFLEX platform that I previously mentioned from systems in all of these pilots, and we have also a model the network topologies in all of them. These include, well, elements from the grid such as buses, lines, transformers, switches, loads, generators, and so on. And all of them we have defined, or we have created a kind of template that makes it easier for the pilots to define these types of elements from their network, and also for us to import them into the GRIDFLEX tool. Moving on, we can see here a kind of dynamic demo of the tool. The initial characteristics that we can show from the tool are a graphical interface with enhanced visualization of the key data of the network. So the high to medium voltage substation in each of the lines of the network, information, so the power in the feeders, the total production in the network. We also have developed some algorithms for 24-hour demand and production forecast for active and reactive power. And for each of the pilots, we have modeled the specific elements, and we provide specific services for this purpose on each of them. As we also saw, we not only have modeled the topologies on a schematic way, but also on a geographical way, as we can see here for the Albena pilot. Moving on, we see here a different representation of the network, in this case the schematic one, which is interactive, and not only we can see the different elements and their status, but also we see the flows of power among each of them. And also in this visualization, we see the results of the state estimation and the load flow analysis of the network that both us and other partners in the project have developed. These types of algorithms increase the observability of the grid. So we have a subset of elements that are telemetered and monitored from each of the pilots, and with these algorithms we can estimate the state of the whole network. So not only the ones, the elements that we have measurements for, but also the ones that we don't have. And we can also calculate the technical losses in the lines, which is also of interest for the grid operator. Also, as a result of these algorithms, we have the congestion detection and forecast, which alerts the grid operator about the potential issues in the network, and is also the input that we use in order to go to the market. So access the flexibility that's offered in the market, in MarketFlex, and try to find the flexible sources in the network that can mitigate these detected or forecasted issues. Moreover, there are also some additional functionalities that we would like to mention. A grid planning and scheduling tool has also been developed as part of GRIDFLEX, which deals with the long-term planning of the low voltage grid in order to anticipate and incidents and reinforce the grid. So it provides scenarios on long-term planning of the network in terms of adding potential assets and analyzing how the network would behave with these future scenarios. We also have the enhanced resilience in extreme weather conditions, which evaluates different measures to enhance the system resilience with forecasted or potential extreme weather conditions such as snow, storms, and so on. And there's also a fraud detection algorithm which takes into account the input from the metering systems of the pilots and tries to identify the suspicious behavior in the electric consumption. So provides a kind of a kind of normal, unclear, or suspicious behavior, a label for each of the users, and when something is labeled as suspicious or unclear, the grid operator is alarmed in order to carry on with some further investigation. Just to finalize, just to mention the target groups and markets. So the main users or actors that the GRIDFLEX tool is aimed at are the distribution system operator, the microgrid operator, and also the energy community. With the transmission system operator and other utilities considered as indirect stakeholders that can be impacted by the tool. The value proposition of the tool, well, we have some key aspects for this. Normally the DSOs or the grid operators have to combine different solutions from different vendors in order to have the complete visibility of the network. So normally they have an SCADA system, a GIS, and so on. And the idea for this tool is to integrate all the data from these systems or from the data sources and have everything in a unique interface that allows the management of these elements and the assets in the network. There's also the tackling of the issues in the grid are normally solved by grid reinforcement or oversizing. And with the inclusion of the GRIDFLEX tool, the idea is to find alternative ways to solve these types of problems. Mainly the flexibility offered by the flexible assets managed by SERVIFLEX, and that they offer their flexibility to the market and try to go this route in order to solve these congestion problems or other type of issues in the grid without the need for reinforcement. And finally, also the resilience against the extreme weather events that we already presented, which normally is only available at TSO level, and with GRIDFLEX we aim at providing this solution also at DSO level. This would be my brief presentation of the tool, and if there are any questions or comments, I will be pleased to answer.
Thank you very much, Diego, for presenting the ETRA tool GRIDFLEX to us and providing this very detailed information about how it works and how users can benefit from it. Thanks for watching to the audience. Please have also a look at the other partner interviews and the other introducing presentations of both MarketFlex and SERVIFLEX, the other tools developed in ETRA. Thank you very much and bye-bye. See you soon.
Bye-bye. Thank you.